Hello, dear students. Welcome back. Myself, Dr. Jyoti Shegokar, as you know, and you are welcome in my channel, Chemistry in Engineering. Guys, our today's topic of discussion is types of wet corrosion. We have seen earlier the wet corrosion and dry corrosion, its classification, and we already have idea that what is the dry corrosion, how the mechanism of dry corrosion occurs, what are the different types of layers possible in dry corrosion. Now moving towards wet corrosion, just unlike the dry corrosion, wet corrosion is a corrosion which occurs due to formation of two separate areas on the metal. You might have idea about the corrosion, considering that we are moving. So corrosion is a decay or disintegration of metal. Decay or disintegration of metal with the action of surrounding. So when a metal it is placed into the surrounding, there occurs the decay of metal itself. That is called as a corrosion. So dry corrosion with the simple action of atmospheric air or the different gases, that is called as a dry corrosion. But moving towards, just unlike to the dry corrosion, there is a particular mechanism of wet corrosion, and we also have idea about that mechanism as it is there in our earlier videos. Okay, now today we are going to see what are the main types or what are the main conditions where there is a possibility of wet corrosion. Okay, now first of all, we will see what is wet corrosion. Wet corrosion is also called as electrochemical corrosion. It is also called as a immersed type of corrosion. So according to its name, electrochemical corrosion, there is a interaction with the help of electrons. Electrons are given and electrons are taken. So like that, when the process occurs, that is called as a oxidation and reduction. So when oxidation occurs, it is called as a corrosion. So that oxidation, it may be by the absorption of oxygen, by taking oxygen, by the removal of hydrogen, by removing oxygen, or by the passing of electron pairs in absence of totally oxygen or hydrogen. When there occurs corrosion, it is nothing but the electron pair donation. So when any metal undergoes the oxidation, there is a removal or there is a donation of electron pairs. Okay, now we are going to see that what are the different conditions in which the wet corrosion is possible. Here you can see there are two different diagrams I already drawn. So here first is a galvanic cell corrosion and another is a concentration cell corrosion. So these are the two main conditions where there is a possibility of corrosion. So firstly, we are going to see galvanic cell corrosion. In this you can see here one diagram, that is a one container in which there is a presence of a electrolyte. It may be water or any electrolyte, and in that here you can see some curved or bent type of electrode has been dipped. So here there are two different type of metals are there. Here you can see the labels. Metal A, which is a blank one, which is just drawn for our sake of convenience, and second is a metal B, which is by the lining it is shown. So metal A and metal B are the two different type of materials. So what is the first condition in electrochemical corrosion or immersed corrosion or wet corrosion? That there are a possibility of two different type of metals. So whenever there is a two different type of metals and two different type of medias, there is a possibility of corrosion, which is called as a electrochemical corrosion. And here you can see that two different type of metals are there and it is immersed or it is dipped partially into electrolytic media. So condition is already made that when two different type of electrodes, means two different type of materials of metal, when two different type of metals are dipped partially into electrolytic media, so it is getting two different medias, air media and liquid media. So when the metal is when two different metals are, they are firstly connected with each other. So they are connected electrically with each other and dipped partially into electrolytic media. In that case, those metal which is in higher electrochemical series, which is having its position at a higher electrochemical series, that means that it is ready to donate electrons in a higher extent comparatively than other. That is the main thing to understand, that when if two metals are there, simply they are looking very similar with each other. But if one metal is having a position in higher higher position in electrochemical series, that is ready to donate electrons very eagerly. So it will donate electrons than those metal which is also having the tendency to donate electron, but in the lesser extent comparatively than this one. So this is the main reason for the occurring corrosion on that metal which is at a higher electrochemical series by creating a potential difference. So here two metals are there and they are dipped simply. So in this one metal, just consider a metal A. It is considered as a zinc, while another metal is considered as a copper. Just consider that it is a copper. So here what will happen, zinc, as it is at a higher position, it is having a just very minimum higher position than the copper, but there is a creation of a difference, so that's why it will be corroded, while the cathode or the another type of metal, that is copper, will get totally protected. So how this occurs, when the zinc is attached with this electrode and it is metal, another one copper, and it is partially dipped into electrolytic media, it just starts to donate electron because it is having a higher electrode potential. So when it starts to donate electron, it is considered as an anode. So in this way there is a formation of two separate areas on the metal. That was the main thing that is here it is proved. So on anode, zinc undergoes oxidation to form zinc dipositive ion. Whenever any metal gives electron, it becomes positive, and this reaction is called as a oxidation type of reaction. While on cathode, means these electrons, when these are produced by the zinc, they are accepted by the copper. So copper, it is already oxidized, that is copper dipositive ions, and it is accepted with the electrons by the process of reduction to form copper metal itself. So copper, it is when it is trying to oxidize, but it will be there protected as it is because of presence of a higher electrode potential metal just beside it or attached to it. So it is looking like a galvanic cell. Galvanic cell is having the same type of a constitution, that two different electrodes are there and they are partially deep into the solution and electrically they are connected. So in that case, here zinc will get corroded, means here a degradation or decaying of zinc will occur till it get totally finished. So that is called as a corrosion, which is a galvanic cell corrosion. It is possible in number of cases. So to avoid such type of corrosion, there must be the use of two different materials. If it is not possible to use a single metal, so use two different type of materials which are having their oxidation potential very much nearer to each other, so that a very less potential difference is created and corrosion will be very slow. So that is called as a galvanic cell corrosion. Guys, I think that you understood this topic properly. If you have not understood, you can write in comments that I will answer. Okay, now second type of corrosion is a concentration cell corrosion. So concentration cell, here there is a creation of a concentration cell. Like here, what is the condition? You can see here there is a one container in which a electrode has been dipped partially, but here it is a single type of material is used in that strip. So that's why it is a single material, same type of metal is there throughout. So when it is dipped into partially into electrolytic media, half portion is below the level and half portion is above the level of electrolyte. So in this way, those portion which is below the level of electrolyte, it is getting less oxygen concentration. Here already it is labeled that it is poorly oxygenated, while uppermost portion is richly oxygenated. So due to the difference in oxygen concentration just around it, it is called as a concentration cell. So there is a formation of a concentration cell. Okay, now this poorly oxygenated portion which is just below the electrolyte, because of it is immersed in the electrolyte where there is a higher concentration. So what will happen here, Fe, it is considered that it is an iron metal. So Fe is going to oxidize. This first reaction is called as oxidation reaction. So it is going to oxidize. Oxidation means to give electrons. So there is a formation of Fe dipositive ion which is a product of oxidation, and those electrons which are produced are accepted by this oxygen or this particular water molecule which is there as an electrolyte. So water molecule and half of oxygen will accept these electrons to form twice OH negative ions. So when these twice OH negative ions are formed, negative and positive Fe dipositive, when we see its net reaction, that is Fe plus half of O2 plus H2O plus electrons will give Fe dipositive plus twice OH negative plus 2 electrons. By cancelling these 2 electrons, there is a formation of there is a presence of Fe dipositive plus OH twice OH negative, which ultimately gives FeOH by 2. So it is a ferrous hydroxide yellow colored product of corrosion. So when this yellow colored product of corrosion, again getting the same condition and same type of material provided, it is continuously getting occurred. So continuously formation of FeOH by 2, and if it is again continuously remain there, it is by getting oxygen again, there is a formation of FeOH by 3, that is ferric hydroxide. By changing the oxidation state of Fe, there is a formation of the another type of hydroxide. So it is a red colored product, and if the hydroxide is removed as a H2O, lastly we will get Fe2O3. From this there is a formation of FeOH by 3, that is ferric hydroxide, and if again by removal of H2O, there is a formation of Fe2O3. This is a ferric oxide. Ferric oxide is produced here, and then lastly when there is a again oxygen will be there, so it becomes Fe2O4, Fe3O4. So it is again the oxide which is the last product, blackish brown product of the corrosion. So in this way rust will be produced here, and continuously if the process is there, continuously this total metal can be destructed in a very short time, or it will require some time according to the availability of oxygen and this concentration. So in this way, by forming the concentration cell, the corrosion will occur. So these are the main 2 possibilities which are possible wherever you will go. So we have already seen our earlier videos the types of corrosion: pitting corrosion, waterline corrosion, stress corrosion, intergranular corrosion. These corrosions are there which are the examples of this particularly wet or electrochemical corrosion. So this electrochemical corrosion is possible in any case. For example, in stress corrosion, wherever the metal is bent or metal is twisted according to giving different type of design to the metal, so there is a possibility of formation of a bent product, and in that, due to that bending, due to that twisting or quenching of the metal, the formation of 2 separate areas is very easy. So by changing the structure also, it is approaching the formation of 2 separate areas and approaching towards corrosion. So according to avoid the corrosion, this particular control measure should be taken, that bend should be very smooth. Then wherever it is possible, don't carry out the quenching or the different type of twisting processes, and use the purest possible metal if it is possible, as because to avoid this type of a galvanic cell corrosion. So in this way we have seen today the 2 different types of wet corrosions, which is very important for the exam point of view. It will be asked for 3 marks each, in which you have to draw the diagram with proper labeling and write its construction and the 2 reactions. These 2 reactions in each of the type are very much important. So in this way it is possible to get all the marks, and also you have to write the explanation of the reactions also, and at least one of the control measure must be there. So in this way today we have seen this topic, guys. If you like this video, like it, share it to your friends, and also subscribe the channel if not already, and also hit the bell button as for getting the videos or updates readily. Thank you very much. Thank you for staying with me. Thank you.